Hello, this is Eric Ahrens with the University of California speaking about Excel for Business Statistics. This is one of my classroom activities in which I introduce central tendency and dispersion and functions in Excel for calculating these statistics. I will include an example from real estate. Let's begin with definitions. Under the category of central tendency, measures of central tendency are often referred to as averages. This is the tendency of some data sets to cluster about a central or mean value. The mean value is the average of the data set values. The median is the midpoint of the data set after the values have been ordered from smallest to largest. The mode is the value of the data set that appears most frequently. Under the category of dispersion, measures of dispersion tell us how spread out the data is from the mean. The range equals the largest minus the smallest value. Standard deviation is a measure of deviations from the mean. Skew is a measure of how symmetrical the data is distributed. I often use Pearson's formula for skew, which equals 3 times the mean minus the median divided by standard deviation. And finally, an outlier is a value far from most others in the data set. Okay, let's look at some calculations using these concepts. In this spreadsheet, I have already entered some data. The data set is 200, 225, 250, 250, 275, and 300. Let's begin by summing it up. Okay, we see that it adds up to 1,500. Next, let's calculate the mean. We can do this in a couple of different ways. First, let's just sum it up and divide by the number of data points. And we see that gives us 250. Next, let's use Excel's function, which is called average. And that also gives us 250. Next, let's use Excel's function to calculate the median. And that gives us 250. We would expect that. As we look up here, we see the data is already ordered from smallest to largest, and the middle value is in fact 250. And let's use Excel's function for calculating mode. And that gives us 250. And as we look up here, we see that's because 250 is the most commonly occurring value in our data set. Now let's move on to the category of dispersion and calculate range. And that is smallest minus largest, so that's cell D7 minus cell D2. And so the range is 100. Now we'll calculate standard deviation using Excel's function, which is STDEV. And we see the standard deviation is 35.355. And next, let's calculate Pearson's skew. I don't know that there's a function in Excel for Pearson's formula, so we have to remember it from the last page. So it equals 3 times the average minus the median we have to get our parentheses right, divided by the standard deviation. And that gives us 0, and we would expect that because this data set is symmetric, there is no skew. All right, next I would like to copy this data over and just paste it alongside here. And I'm going to change the last data point from 300 to 500. So I have intentionally introduced an outlier. And I'm going to sum these up, and I can do it just by dragging this lower corner across. And we see the sum is now 1,700, which is 200 more than the previous, and we expect that. Next, I would like to calculate the mean, and I can do the same thing with each of these. I drag them across, and I see the mean value is 283, and that also makes sense because with this outlier in here of 500, we would expect the average value to go up. Then we have median. I drag that formula across, and we see the median did not go up. And that's because the middle value is still here at 250. The median is not affected by an outlier. And with mode, we calculate that, and we see the same result. The mode is still 250 because that's still the most commonly occurring value in our data set. Now let's calculate range. And we see range went from 100 to 300, which makes sense because we now have this value of 500 up here. The standard deviation, let's see what it did. It went from 35 up to 109. So the data is much more spread out now due to that outlier. And finally, let's calculate Pearson's skew. We see that that went from 0 to 0.91 because our data set is no longer symmetric. Okay, now suppose this original data set is a real estate sales data. So we have a neighborhood of all similar houses, and they've been selling for one house sold for 200, 225, 250, 250, 275, and 300. Now imagine that a house caught fire and the one next door burned down too, and somebody built a large house across those two lots that's selling for 500,000. That's an outlier house, isn't it? So as we look down here into the mean value, because we put up that large house in the middle of that neighborhood, does that mean that the average value of all the houses went up? Probably not. And this is why people in the real estate business use the median instead of the mean for their measure of central tendency, because the median is not affected by an outlier house within the neighborhood. Okay, hope you found this interesting, and most importantly, I hope you will practice these calculations. As you probably already know, we can't learn math or computers unless we get busy and do it. We have to learn by doing. All right, thanks for listening.